Welcome back to Rice.AI Code Room. Today we are tackling LeetCode 1855, maximum distance between a pair of values. Let's review the problem statement. You are given two integer arrays, nums1 and nums2, both sorted in non-increasing order. We need to find a valid pair of indices I and j, such that I is less than or equal to j, and nums1 of I is less than or equal to nums2 of j. Our goal is to maximize the distance, calculated as j minus I. Before writing any code, let's clarify the constraints. The arrays can have up to 100,000 elements. A nested loop checking all pairs would take O of n squared time, which will definitely time out. We need a more optimal approach, taking advantage of the fact that the arrays are already sorted in descending order. Here is the thought process. We can use a two-pointer technique. Let pointer I traverse nums1, and pointer j traverse nums2. If nums1 of I is less than or equal to nums2 of j, we have a valid pair. We update our maximum distance and increment j to explore if an even larger distance is possible. If it is invalid, it means nums1 of I is too large. Because the arrays are non-increasing, moving j further right would only yield smaller values, making it even more invalid. Thus, our only option is to increment I. Let's write the implementation in C++. We initialize two pointers, I and j, both starting at 0, and a variable max_dist to store the result. We loop while both pointers are within their respective arrays. If the condition is satisfied, we update the maximum distance and move j to the right. Otherwise, we move I to the right. Finally, we return the maximum distance. Finally, let's analyze the complexity. The time complexity is O of n plus m, where n and m are the lengths of the arrays. This is because both pointers only move in one direction and never backtrack. The space complexity is O of 1, as we are only using a few variables for our pointers and to keep track of the maximum distance. Thank you for watching Rice.AI Code Room. See you in the next video.